We are in 6.2, so applications of normal distributions. So with normal distributions, we always have a mu of 0, standard deviation of 1. But in the real world, that's not going to always be true. You're going to have different means and different standard deviations. But you can use the same application that we did on 6.1 to find the z-score and also to find the probability or the area. So this is a way of converting values that aren't standard into standard, like with mu of 0 and sigma of 1. So this is our formula. The area of any normal distribution bounded by some score x is the same as the area bounded by equivalent z-scores in standard normal distribution. So you can use the table. So the table that we have, it also goes along with having a mean of 0 and standard deviation of 1. But that's not true in every situation. So we convert it. We convert whatever the x value is that they give us into a z-score by subtracting from your mean and dividing by your standard deviation. And that gives you your z-score. We learned about z-scores several chapters ago, so we're coming back to it, and we're going to be able to find the probability under the normal curve. So here is my non-standard normal distribution, where mean is just mu, p is the probability, and then x is some number. We use this formula to convert it to a z-score, and that way we can use the table. So to find areas with a non-standard normal distribution, first thing you want to do is you want to sketch the curve. You know your mean is in the middle, and then above it would be positive z-scores, and below it would be negative z-scores, or anything below the actual mean. Shade the region corresponding to the desired probability. For each relevant value x, that is a boundary for the shaded region, use the formula to convert. So that formula is z equals x minus the mean over standard deviation. And then use the table or the graphing calculator to find the area of the shaded region. So remember, to find the area, we're going to use normal CDF in our calculator. And that's found under second vars, normal CDF. Okay, so we can use the calculator or we can use the table. So example 1. The safe load for a water taxi was found to be 3,500 pounds, and the mean weight of a passenger is assumed to be 140 pounds. Let's assume a worst-case scenario in which all the passengers are adult men. Based on the data from the National Health and Nutrition Examination Survey, assume that weights of men are normally distributed with a mean of 172, so I'm going to go ahead and underline that, and a standard deviation of 29 pounds. So go ahead and write that. Go ahead and write those two values down. If one man is randomly selected, find the probability that he weighs less than, so we're finding the probability that he weighs less than the 174. So it says the mean weight of men is 172 with a standard deviation of 29. So this is a real application. We want to find, so it says find the probability that he weighs less than, so x is less than 174 pounds. So probability is going to be the area under the curve. So we can't just look at these two. We've got to convert it to a z-score. So our z-score is going to be found by doing x, which is the 174, minus your mean, and dividing by 29. And this finds the z-score. How many standard deviations away are you from the mean? I'm going to clear this. I'm going to put it in calculator. I want to change that to a decimal. So my z-score is 0.0. I'm going to do 69. Well, actually, using the table at 0.07, we just go to the hundredths place. So it's not very far above the mean. So it's actually drawn here, which it's kind of hard to see because it's not dark. But in the original, our mean is 172 and our x value is 174. So it's just a little bit above. We're wanting to find the area. So we convert it to a z-score. So a mean of 0. The z-score is 0.07. We want to find the area. So we can use our table to find the area. So we're going to go, it's a positive z-score because it's above. And we're going to go to 0.07. So it's up here, 0.0, and then go over to 0.07, 0.5279. So this equals 0.5279. We also know how to do this in the calculator, right? If we're finding area, we're using that normal CDF. So whenever we do the normal CDF, let's go ahead and I'm going to show you my calculator. You do second vars, which is the distribution, normal CDF. The lower is going to be, because we're finding this area, right? I didn't shade that just because it has the answer there. Negative 1 E99. And then all the way up to, what do you notice about this? You have mean of 0, but could we change that? I first need to do upper. Do y'all want to see something that's really helpful? We can actually change that to 174 and change our mean to the actual mean that we're given, 172, with a standard deviation of 29. So if we look at it, this is the exact answer. This is the rounded solution. So in calc, we got 0.5275. So that's the exact answer. So our table gives us an answer, but the reason it's not exact is, remember how we had around this originally? And then look for that on our table. But the calculator will do the work for us, which is good. But I do want y'all to know where this all comes from and how it relates. So this is just a explanation of it. So using the table A2, we find the cumulative area to the left, 0.07 is, we're going to put 0.5279. So there is a probability of 0.5279 of selecting a man with a weight less than 174. So a little over half. Also, blank of men have weights less than 174. So that'd be the same, 0.5279. And blank have weights greater than 174. How would we find what's greater than that? Subtract by 1. So do 1 minus 0.5279. 0.4721. So on the Pearson, just make sure you pay attention to what it's asking you to round to. All right, let's look at example 2. A psychologist is designing an experiment to test the effectiveness of a new training program for airport security screeners. She wants to begin with a homogeneous group of subjects having IQ scores between 85 and 125. Given that IQ scores are normally distributed with a mean of 100 and standard deviation of 15, what percentage of people have IQ scores between 85 and 125? Let's draw the normal distribution curve. You need to close your computer, please. So of our normal distribution, what is our mean? 100. And our standard deviation. So let's go ahead and plot 85 and 125. How many standard deviations is 85 from 100? It's just 1. If we take 100 and subtract 1 standard deviation is 15. So it's just 1 standard deviation away. And then 125, how many standard deviations away is it? It's a little over 1, almost 2, right? So 1, almost 2, so something like that. Doesn't have to be perfect. And they want to know what percentage of people have IQ scores between 85 and 125. So go ahead and draw those lines. We're wanting to find the probability between here. So it's in between these two. So we can actually use our calculator on this. We can do normal CDF. What's our lower? Lower is 85. Upper is 125. They've given us the mean of 100, standard deviation of 15. So remember, we use normal CDF to find the area, which is your probability. So what is the probability of selecting an adult with an IQ score between 85 and 125? So probability of selecting between 85 and 125. So it's the compound inequality between 85 and 125, and we get 0. Let's go to 4 decimal places, 7936. So almost 80% of people will fall between those two IQ scores. Okay, I want you to go ahead and read the next one and do the next one on your own. I do need you to draw a picture of it, though. women have heights that are normally distributed with a mean, I'm going to go ahead and write that, of 63.8 inches and a standard deviation of 2.6 inches. What percent of women, so probability of, X is at least? What inequality symbol do I use for at least? Greater than? At least, so greater than or equal to 70. So let's draw our normal distribution curve with our mean in the middle of 63.8. How many standard deviations does that fall? Like, how far away is that? I just use this to kind of help me look at where it'll be. Well, I guess I should do 70 minus 63.8 divided by 2.6. It's more than 2. So it's like right around here. So which way am I going to shade to be at least 70? To the right. So this is going to be a small percentage. All right, so we need to use the normal CDF. But what is our normal CDF? How are we going to have to adjust this? Let's see. What's my lower? 70. I'm just going to put L, 70. What's my upper going to be? Then mu and sigma. So the probability that someone randomly selected, a woman's height is above 70 inches tall, 0.0085. 70 inches tall. How many feet is that? 70, was that 5'10"? Is that 5'10"? Wow. So that's a really low percentage, right? All right, let's keep on rolling through this. I'm going to skip 4. We're going to go on to, now we're going to find the values from known areas or probabilities. So we were finding areas. Well, now we're finding the z-score or the x value given a probability. So the first thing you want to do is sketch that normal distribution curve. And then decide which side is it going to be on depending on the percentage or the area. Then you could use a formula x equals mu plus z times sigma. And then refer to the sketch of the graph to verify the solution makes sense. So try not to confuse z-scores and area. So z-score is distance along a horizontal scale. Z-scores are between, usually, negative 3.5 and positive 3.5. So you can have a negative z-score. But areas, those are probabilities. And that's only between 0 and 1. So if you get something outside these for either one, then you might have done something wrong. But this is our z-score. This isn't just an x value that we can, this is whenever your mu is 0 and your standard deviation is 1. Area is always between 0 and 1. You're going to choose the correct left or right side of the graph. A value separating the top 10% from the others will be on the right side. So draw your normal distribution curve. So it says the value separating the top 10% from the others. So what percent would this side be if you're looking at top 10%? If this is considered your top 10%, what is this side going to be equal to? Yep, 0.9 or 90. And then a value separating the bottom 10% will be located on the left side. So this is top 10% on a normal distribution curve. Okay, on C, a z-score must be negative if it's located on the left half of the normal distribution. So if we're talking about mean being 0 and our standard deviation being 1, this is your mean in the middle, 0. And anything to the left would be negative z-scores. Anything to the right is positive. Areas are positive or 0, but they are never negative. So you'll never have a negative probability or a negative area. Okay, in a previous example, we found that 52.79% of men have weights less than the value of 174 pounds set by the National Transportation Safety Board. What weight separates the lightest 99.5% of men from the heaviest 0.5%? Again, assume that the weights of men are normally distributed. So our mean is 172. Our standard deviation is 29. So the normal distribution curve that they gave us is right here. And it says we're looking at the heaviest 0.5 with the lightest 99.5. So I'm going to redraw it just because I don't like how that looks. So I know that this is 172. So the lightest to the heaviest. So we know this is the point that separates it. This is what we want to find. It says that the area, the lightest, so this is going to be 0.995. And we want to know what that number is. After they've given us the probability, the area, I mean. So we can actually use the inverse normal in our calculator. So you use inverse norm when you're trying to find the z-score or the x value that's here. When you know the area. So I know the area, and you always want to go area to the left of that number. If you don't know the area to the left, you've got to find it before you use inverse normal. So the area is 0.995. Our mean is 172. Standard deviation is 29. So whenever it talks about area on here, it's always to the left. So my x value is 246 point, let's do 7. So we need to know what this means. It says, what weight separates the lightest 99.5% of men from the heaviest 0.5%? So the weight of 246.7 pounds separates the lightest 99.5% from the heaviest 0.5%. So this is saying that 99.5% of men weigh less than 246.7. That's what that says. We're going to skip example 6 and go on. Go ahead and read the next one on your own. We're going to do 7 and 8. These are the last examples. Go ahead and draw the normal distribution curve. So let's look at the normal distribution curve on this one. So we have a mean of 27, standard deviation of 1.3. It says find the forward grip reach of women that separates the longest 95% from the others. So the probability or the area that we're looking at is 0.95. So a majority of women, we want it to fall within that area. So I would say something like this. We want to know what that reach is. And so we want this area, or we have this area actually. So 0.95. We want to know what that reach is. So we can use inverse normal with the area of 0.95 with a mean of 27 and a standard deviation of 1.3. So 29.1 inches. So that's what goes here. So 95% of women have a grip reach of 29.1 inches. Some educators argue that all students are served better if they're separated into groups according to their abilities. Assume that students are to be separated into a group with IQ scores in the bottom 30%, the second group of IQ scores in the middle 40, and then the third group IQ scores in the top 30. The IQ scale scores are normally distributed with a mean of 100, standard deviation of 15. So which scores separate them into three groups? So let's draw our normal distribution curve where our mean goes in the middle of 100. So it says bottom 30%. So let's draw a line for that bottom 30. So this right here is going to be our bottom 30. Bottom 30%. So we want to know what that value is. Then it says the second group is the middle 40 and then the top 30. So it's going to be symmetrical. So we want to know what that is for just this area to be 0.4. And then this area to be 0.3. How could we go about finding each of these two? Which one's the easiest to find right away? We're going to have to find this one right away because that's area to the left. So let's find this one first. So we're going to do the inverse normal. And the area is going to be 0.3. Our mean is 100. And standard deviation is 15. So go ahead and put that in the calculator. So we know it's got to be below 100 because 100's right there in the middle. It's your mean. $92.1. So our bottom 30% is the scores that are where X is less than or equal to 92.1. An IQ score of 92.1. So we can put that here, 92.1. So then we've got to find this number. What is the area to the left of that, though? It's going to be this whole thing, not just the 40. It's going to be the whole thing. How much is that whole percentage right here? Bottom 30, middle 40. We're going to use this whole area from here all the way over. That whole thing is 0.70. So we got to use inverse normal again and find where the area is 0.70. The only thing that changes is the area. So 107. 107.9. So the middle 40 is between 92.1 and 107.9. And then the top 30% is going to be anything above 107.9. So it's where x is greater than or equal to 107.9. We've already gone over how to use the calculator. We use, to find the area is normal CDF. Make sure you make notes of this whenever we have a chapter 6 test. You know the difference. Where do you use normal CDF? That's to find the area. And then inverse normal. Use that to find your z-score or the x value. So the next one is find the value. Use inverse normal. Okay, we're not doing these two examples. When dealing with normal distributions, always remember, draw the graph to visualize the information. Determine whether we want to find the area or the inverse. We usually work with cumulative area to the left. So if they've given you the right side, just subtract from 1 to find the left side. And then z-score and values are distances along the horizontal scale. Percentages or probabilities correspond to area under the curve. All right, that is it for 6-2.